So I have the pleasure to present 3 success stories in consecutive. So my colleagues, they prepared all the demonstrations, but they gave me the chance to present this. So if you have any really detailed questions, they are very happy to answer them, just to be sure about this. So what I'm talking about are 3 different types of research projects where we dealt with AutomationML in the last few years. So what we see is that AutomationML gets stronger and stronger, not only in the research area, but also in industrial projects. This means that normally if we work with AutomationML, we base on some general principles. And these principles, they show up in every of these 3 projects. These are only 3 examples which we can show. And the first is called Secure Plug and Work. After that, we have plug and control for flexible conveyors. And we have mobile monitoring, which is called. And all these ones have different principles. On the one hand, you have always the description or even self-description of components via AutomationML. You have assistant functions or fusion techniques to work with AutomationML. You have a communication or data management or a validation of AutomationML via OPCOA. So we combine it also with other standards, like for example, Phoenix does it with eClass. And we have the combination with different middleware software. We have the combination with different field buses logically. And we have also the test, the realization of the components, and the evaluation of these things, not only at the industrial partners demonstrations, but also at our demo factories here in-house, to have something which can be shown, which is independent of all the company information and non-disclosure agreements, but which really can show the strength of AutomationML. And what you see here on the right side are different examples which are existing here in-house, where we can show some things with AutomationML. So what we see is that on the level of manufacturing execution systems or production control systems, on the first level, complexity level, there are always existing signals, and there are still systems which are dealing only with signals. On the next level, you already have resource objects. This means that you couple your signals to objects. This means that, for example, for a visualization tool, for an evaluation tool, for an analysis application, or even for a new application, you can deal with those objects and group information which are coming from the signals down to earth. On the next level, and this is what we are thinking of if we are talking about Industry 4.0, there are semantic models. And AutomationML for us is one example to deal with semantics, perhaps not the high sophisticated one, but the most practical one, which can be used. And our vision or our idea or our general basic thing is that we see that there are a lot of existing models already, which are focusing, for example, on products, processes, or even resources, and that these models must be interlinked somehow. But that normally there are so much special aspects in these models that you are not able to link every little detail. But you need something like the glue, and this glue for us, logically is AutomationML. So the principle, which is the base for all the examples of the projects I will show now, is very easy to explain. You always have some data sources. You have also know-how. And this is perhaps this little brain, which must be more bigger because the people, they do a lot of input into the engineering phase. And you have always an import or fusion step to get all this information into AutomationML. After that, you have a generation where you extract a specific view, specific data, parts of the AutomationML model, and in the end, sure, you have to export it and these two steps are dependent on the source and the system where you want to go for. But this step in the middle, this is the general one where you can reuse things. But in the end, if you, for example, if you're dealing with a visualization system or an HMI like WinCC, you have to be in the data format of WinCC if it does not support the AutomationML import. So in the end, you must have something specific. If this export is provided by the tool provider, it's very good for you. If not, you have to write it. And on the other hand, you see below this little OPC-UA thing. This means that all this data, this transport of the AutomationML data can be realized by OPC-UA, by a communication technology, which is also used in the production level, in the field level. And for sure, in the end, if you have then online signals in the MES layer, for example, OPC-UA is also often used to connect the systems directly to the production plants. But now to go into the examples and the concrete things, we have a running publicly funded project called Secure Plug and Work. And there are a lot of partners from the production domain, for example, from machine tools, from washing machines, from component manufacturing, and they all have one vision to plug in some components, for example, in a machine tool, and to get those components working with minimal amount or minimal manual effort. This means that most of the information shall be transferred automatically. And one thing to be used there is AutomationML. So to get back to that example, we have a description, an AutomationML description for each of these components. And the components vary from gripping systems to spindles to, for example, such spindle heads. And they put in a lot of know-how from the component manufacturers in the AutomationML model and put this all together to, for example, create out of a spindle and a multi-spindle head and, for example, such a screwball, a whole machine tool where every of the component is integrated. And what is used there is OPC-UA to transport the information, to give the component not only the ability to provide its self-description, but also to communicate it. On the other hand, the highlights from this project are that within the project, the use cases are very different from their specification, from the domains where they have to work in. But also we have a lot of challenge to fusion the different parts to provide information about the process data, the real running data coming from the field buses, for example, Profinet or CanOpen, or for example, Modbus TCP. The generic thing or the common thing is that all the components, all the systems, all the system modules provide their self-description. The self-description is fusioned, and we have after that a running system. And these things are really hard to realize and hard to understand because they are so complicated, so that one focus on the project lies on creating assistant tools to the component manufacturers to deal with AutomationML, to hide complexity of AutomationML, to know how to generate AutomationML models, but not to give them the whole complexity of AutomationML, but to restrict it. On the other hand, we have a project called Plugin Control for Flexible Conveyors. There we have another situation. This project was finished, I think, during the last month. And there we are dealing with such conveying elements which are really modular. So this means that they are not only modular in their control code. controller technology, but that they are modular in the sense of mechanical and electrical interfaces. So this means that they are really able to be plugged, and they have such an algorithm for the transport step. And this means that in the end, we thought that if they already provide a self-description, why not do this via AutomationML? And why not also connect, for example, visualization systems like WinCC or like proprietary visualization from this company? And this means that in this project, we had those self-descriptions containing CDL, which means Conveyor Description Language, and STEP. We have a lot of know-how, which is imported. And there we deal not only with the CAX part of AutomationML, but also with the graphical representation, the CAD data. And we generate different views on the elements. We take the relations between the elements, and we generate the whole visualization for Provis Visu, Siemens WinCC, and the Gebhardt Visu. So this means that this is one example where the data, the self-description, was already there in the beginning, had to be adjusted a little bit, but where you can really use AutomationML in the middle to have a really not proprietary data format. And I just want to show a little demonstration about this. What you can see here is an existing plant. Just have to search for my mouse. So, and if I now say that I give the plant, so I plug the conveyors. We cannot do it here in live because we have no conveyors here. But if we are plugging the conveyors, each conveyor communicates via an Ethernet overlay network. They put all together their self-descriptions, and this is what we can show now, that if you have the self-descriptions, all the data is taken, and we generate from the CAD data we get the visualization, the view on the components which can be used for the visualization systems, for example for WinCC. So this step is independent on the export which you do in the end, because generating the view on the objects is a thing which you do on the graphical representation, on the graphical information, and not dependent on a system where you want to use it in the end. But as all the systems, for example, are only supporting bitmaps or, for example, polygons, we are relying on those generic elements and generating the whole thing for every of the elements. And after the generation is completed, the new images is built up by the information how the topology looks like. So topology means in this case that the connection between the plugs is recognized. And this means that, for example, the plug between the system of number 110 and the plug of the system 116 are set. So we do not have an explicit location of the element, but we know the relation between them and can build up the visualization based on this information. And for such a transport equipment, this is enough to represent the whole transport system. And they do not have to paint or create any picture, but we are able to provide, for example, detailed information to the elements. We can connect, for example, OPCUA variables, which are described in the AutomationML file, and we can generate the whole visualization system. So this is another example where you can use AutomationML already today. So the highlights is that there's a proprietary description, and that we use, for example, 3D data from the engineering design, which we convert from STEP to Koyada, and that we identify the visualization relevant objects in the model to generate the visualization in the end. So at least there are also some in-house projects at Fraunhofer where we try out something. And one thing was that we have colleagues which are dealing with the domain of water analysis. And this is really not a production use case, but we said that if you're doing analysis on sensors which are measuring water quality, for example, this is not so different from the values you get from production sensors. So this means that we said, okay, you have the same base as we have. You have a topology of a system, you have sensors, you have real values, and you do an analysis on these values. So for this example, we have, for example, they do not have CAD data for the sensors, but they have such images, so bitmaps, for example. They have their know-how. And we import that and create an AutomationML file. And what we do then is that we say, okay, based on this AutomationML description, you can figure out what is contained in your system. So how much sensors, what they are measuring, what kind of sensor you have, for example, or what the sensor value, for example, actually provides us information. And what we do there is that we take all this information and just generate such visualization things. And the good thing is that in the water domain, they use also similar standards. For example, they used OPC. And we said, okay, like in the production domain, you could also use OPC UA, you could use OPC. We can describe the connection information also in AutomationML. And this means that we can completely generate the images. And the thing here is that we cannot only generate them for one visualization system, but that we are able to generate it, for example, also for mobile visualizations, because for the water quality, you are not able to send or to have a control station at each sensor, but you normally have mobile mobile stations where you can control the analysis results. And if we now look at these images which are generated, we are able to show, for example, the water quality. We can show, for example, different types of sensors. Yeah. So, and you have the information of the actual values of each sensor which are connected via OPC UA. What we can do now is that they have such an event detection, our colleagues, because they're doing condition monitoring. This means that they get those sensor data and they see where errors occur. They see where you can use, for example, from which percentage, which sensor does contribute to a current error in the water network. And this is what we can simulate now, so we can decide whether we want to generate alarm resulting of a high chloral, high chlor in a water work or in the water network. So we take the water network and we say, for example, the alarm should occur from the sensor 129, which is 6. So, and now we have a contamination which we can see in the water over there. So we see that the sensor 129 is recognized as as resulting sensor for this alarm, which was calculated by the monitoring by the monitoring tool of our colleagues. So this is just one example where you can use AutomationML even if the domain is completely different, if the information you store is completely different, but the mechanisms which we use there are completely the same, like in the last example for the flexible conveyors. Because we also use AutomationML, we describe the topology, we generate the visualization, we connect the elements via OPC UA to get real-time data. So the basic principles are always the same, but we use AutomationML just as neutral data exchange format, just as information thing. And this is also the information we want to provide. If you want to have a look at the mobile devices, my colleague has them with him, which show the same pictures, just to have some running examples. But the thing really is that all these applications, all these projects from the research or the industrial domain, they all have in common that we can use standards to resolve their problems. And in most of the cases which we are actually dealing with, AutomationML is a topic. And this is what we wanted to provide today. So thank you.